Okay guys, we're going to do a quick separable differential equation to get your feet wet again and remind you of some things that we were doing before spring break and spring service trips. So in this example, you can see that this is definitely a differential equation, a separable differential equation because I've got y's and x's mixed up over here, so my job is to separate them. A general first move is to multiply by dx on both sides. So we're going to have the result then of y times 1/5 minus x over 60 times dx. And then it's pretty obvious that the major term that needs to move now is the y, and then everything will be separated. So a lot of you have been writing that as dy over y equals 1/5 minus x over 60 times dx. And I want you to get in the habit of separating this over here into 1 over dy equals the same result on the right hand side. We've successfully separated now, and I hope you remember that once you've got your variables separated, our next move is to do some integration. So from here, I'm asking myself what the antiderivative of each side is. On the left hand side, pretty straightforward, the natural log of the absolute value of y. Over here, you might need to pause for a minute, especially on the second term. First term, not too bad, 1/5 x. And on this next piece, I'm going to urge you to take out the 1/60th from your processing and just focus on the antiderivative of x. And we'll just multiply by that factor of 1 over 60 when we take the antiderivative and get 1/2 x squared. And then, of course, we cannot forget Charlie. So a cleaned up version of that would be the natural log of the absolute value of y equals 1/5 x minus 1 over 120 x squared plus c. My advice in this particular problem, and generally speaking, is to isolate y so that things can really simplify over here on the left. To isolate y here, we'll exponentiate both sides of the equation. That leaves us with the absolute value of y equal to our good friend Super Charlie, e to the 1/5 x minus 1 over 120 x squared. Remember, I snipped over it, but our initial condition was y of 0 equals 3, and more specifically, y of 0 equals positive 3, which means when I drop these bars, sorry about that, I have to include plus or minus, and I'm going to keep the positive solution because my initial condition is a positive 3. So I'm in a place now where my solution is looking like y equals big C e to the 1/5 x minus 1 over 120 x squared. All right, and now to finish off, we will use that initial condition to solve for c. So it said that when x was 0, y was 3. So I'm going to plug in a 3 for y, and everywhere there's an x over here, I'm going to sub in the value 0. And I'm just getting fancy with my colors here, so be patient with me. But what you'll notice then is we have a much simpler expression, especially when we do our simplification. We get 3 equals c e to the 0 up top. E to the 0, remember, is 1, so it looks like Super Charlie is a value of 3. Therefore, my final answer is y equals 3 e to the 1/5 x minus 1 over 120 x squared. Biggest takeaway here, guys, is that you have to separate your variables, get y's on the left, x's on the right, and then do your antiderivatives to each side. Solve for y, use your initial condition to solve for c, and then set up your final equation. There are tons more videos on YouTube. Please feel free to check those out, but good luck on your homework. Due tomorrow. See you soon.